so we're going to start on page 20 in your packet. Okay, and that's our chapter 3 notes. And so go ahead and get open to page 20. All right, homework, by the way, is going to be pages 24 to 29. So quite a few pages, so I want to get this lesson taught as quickly as possible so you have class time to work on that. All right, so we're going to do 3 concepts. First is that standard deviation of slope and standard deviation of residuals. We're actually just going to review this because I had already taught that with the computer printout lesson with our songs. All right, so remember that our standard deviation of the slope is happening because we get different samples. And from sample to sample, they will vary. Therefore, we get some different, so from person to person, we get different sample or different slopes, different samples which give us different slopes. So remember that our song was hello, and if we sample many times, I'd expect the slope you find of the relation between x and y to vary this much. So it kind of tells you how much that slope can be off and be reasonable, to vary this much on average. Okay, so we're going to kind of draw some of that variation to remember that. So if you want to put your line through there, and then let's say the standard deviation, so that's a slope of about 1.5. I just am estimating this and just eyeballing it so you get an idea. So the standard deviation of the slope is 0.25. So somebody getting a slope that's a little steeper, so maybe 1.75 is fine. Somebody getting a slope at, say, 1.25 is fine, and so on. So we're going to get different kinds of slopes going on through this. So remember that if I had something more than 2 standard deviations up, I would be concerned about that slope and think that that's pretty strange. So if I had a slope greater than 2 in this case, or if somebody had gotten a slope that was less than 2 standard deviations below, which is a slope of 1. So if you had a slope greater than 2 or a slope less than 1, I would be concerned and think something is going on with your data. You probably need to check it out. You've got an outlier set of information, what's happening there. Okay, next, that standard deviation of residuals. So this is that average distance that the actual y, so remember our residuals are actual y minus the predicted y. Well, we're getting the average of all of those points. The average amount that the actual y, so the average amount that that actual y varies from the predicted y. Okay, so our song was to Billie Jean, the average amount that the actual y value point, varies from what's predicted to become, varies from the predicted y. Okay, so I have here a residual plot, okay, and we're going to say that on average you would expect it to be whatever this prediction line is, and then we have a standard deviation or a residual. Standard deviation of the residuals is 3. So one standard deviation up is 3, and then 6, and then 9, and so on. And you're going down standard deviations. So essentially, if you get something going more than 2 standard deviations out, they're going to be outliers. So you could identify some outliers here. You also should notice, and we did this the other day, that there's more data here closer to the center. In fact, as we discussed, 68% of the data should be within 1 standard deviation, 95% of the data should be within 2 standard deviations, and then of course our 99.7% should be within 3. And let's look at our data, see if there are any outliers. Are there anything past this 2 standard deviations? And it looks like we do. We've got 2 values there that end up being outliers because they are past the 2 standard deviation mark. All right, so that is our standard deviation of the residuals review. Okay, moving on to the next page. This concept is now new concept. All right, so this is another way to write the equation of the line, or that least squares regression line, if you've been given information other than all the data points. Okay, so you haven't been given the lists of the data points. So the other way that we can do this is we can calculate, or we have to be given the correlation coefficient, the standard deviation of the x data, the standard deviation of the y data, and then the mean point. So the mean of the x's and the mean of the y's. All right, so you actually are given quite a bit of other information. So here we go. The first of these three items first thing that we have to do is get the slope. And the slope is a formula. If you remember in the past, how do you get slope? Just regular old Algebra 1, how do you get slope? Well, if you remember, it's the change in y's over the change in the x's. Okay? But here, we kind of have something similar to that. We've got the variation over the variation in the x's. So we still have that kind of rise over run relationship. It's about how much the variation in the y's over the variations in the x's, and it's times how well that data is correlated. So times the R value. So that is the first thing to do. Now, you do not have to have that formula memorized. On the AP exam, I wanted to show you that on your formula chart, which you have your pink packet of formulas, on your formula chart, down here, almost to the bottom of that first column, is this. So we've got all the way down here, it listed as B1. And the reason it listed as B1 is because the y-intercept is B0, so the next point up, they call it B1. And so that creates that particular type of slope. So this here is on the formula chart that you can use all the time, the slope formula. All right, now, after you do that, then you have the slope. And you need then a point on the line. Well, the mean of x and the mean of y is, so the average in the x direction and the average in the y direction is always going to be a point on the line. Okay, in fact, I have a little ditty to remind you of that. So we're going to take a look here. It's kind of a coffee house version of Shake It Off instead of the regular old pop version, but here's this one. Y bar is the mean of y, and the mean point is always on the line, on the line. X bar is the mean of x, y bar is the mean of y, and the mean point is always on the line, on the line. X bar is the mean of x, y bar is the mean of y, and the mean point is always on the line, on the line. All right, so therefore, we know that this mean point is always a point on the line, and so the rest from there is Algebra 1. So let's practice that. Here we go. Okay, we have this situation. Becky's parents kept the records of her height since she was born, and so you can see we've got the mean of her age and the standard deviation of her age, and we've got the mean of her height, the standard deviation of her height. So of the age and height, which one of those do you think is the explanatory variable? So the x's. Okay, so we're going to do that age, the mean of x, and then we've got standard deviation of x. And then for the height, we've got mean of y and standard deviation of y. So we have all of those items. And then we have that the correlation is 0.86. So we're going to find the equation of that. And the first thing that we're going to do is get the slope. Okay, so that of course is our correlation times standard deviation in y over standard deviation of x. So make sure you get that direction correct, which one number goes on top. So I'm going to fill these in here and then get our slope. Okay, so I did that computing, and so the slope is 0.41. All right, and then I know that the point that I will use is going to be 44, 82. That is the mean point. It's always a point on the line. The mean of x, the mean of y, that's a point on the line. So there are different ways you could do this. You could use point slope formula. I like to do it this way because we need still the y-intercept. I like to do this information. Okay, because we've got then 3 out of the 4 items in this equation. We've got the mean of y, the slope, and the mean of x. And so I can fill those items in, and then I can get my y-intercept. So that's what I like to do. So let's go ahead and do that here. My mean of y is 82. My slope we computed is 0.41. My mean of x is 44. And then I solve for the y-intercept. Okay, so then I'm going to subtract that over, and my y-intercept that I find is 63.96. Okay, so therefore I can write my least squares regression line is predicted height equals 0.41 times the age in months plus 63.96. See, I'm writing an official line, so I did that with my prediction hat, and I did that with our words. Prediction hat, and I did that with our words. Okay, well, if you take a look at the next one, it actually is just, I think it's just some computation stuff. It's not even context. So let me give you a few moments to try this one on your own, and then I'll just flash up the answer here and let you check that. So try that now. All right, so here's all the work on that, and you could pause the video right here if you wanted to stop and take a look at that. The final answer ends up being predicted y equals 0.17x plus 0.095. I rounded that slope to 2 decimal places. So pause that here if you need to take a look at that information. All right. This next example is goes about getting things in a backwards direction. You actually have all of the data points, so you wouldn't have to use all of that fancy stuff that we just did to get the equation of the line. You could go ahead and put this into your calculator and get the equation of the line. And so, of course, we would expect that the explanatory variable is the number of cigarettes per day, with the birth weight being the response to that. But I wanted to show you a feature of the 2 variable stats on the calculator. So if I went and put this information into my lists, 1 and 2, and you can just kind of watch along here. You don't have to necessarily do it with me for time's sake. So I have that done. I'm going to go stat over to calc, and we have done 1 variable stats in the past, but now we're going to do 2 variable stats, and all that does is calculate the information for the x variable and then the information for y variable at one time. So it's just going to do 2 sets of data at once. So what I can see from that is that the mean of x is 18.17. The standard deviation of x, because that's the other thing I'm interested in, is 8.26. Okay. Then if I scroll down on my calculator, I can see the information for the y values. So y bar, which is the mean of y, and that is 5.95. And the standard deviation of y on our calculator is 1.01. Okay, so I've got those 4 items. What's missing to be able to do that process, that previous process, is to do the get the R value. And strangely enough, to get the R value, I've got to actually just go calculate the linear regression. So this page is kind of strange because it's like, you're getting what you need. It's right there. Why am I having to do all this math? But I just wanted to show you how you can access all of this information. It's negative 0.95. Okay. All right. So from that, you could then go and do the process we just did previously and get the equation of the line. In fact, I think on the homework, the first problem I had asked you to come up with these summary statistics, and with that you're having to get that from 2 variable stats. And then I said use the above space to calculate the equation of the line. Don't use your calculator. Basically, I was hoping that you would use this process here and show using this information. Okay, so it's a little redundant. But I tell you what, this lesson, there's so many pages to this assignment that I'm going to kind of nix that. If you want to just go ahead and get the LSRL from your calculator, that's fine. Let's just move on from there. All right, final concept of your lesson is about the correlation coefficient R. You know, we're interested in how transformations affect our data. And the interesting thing about transformations affecting R is that nothing affects them except for multiplication by 1 negative. You know, R measures that strength of linearity. So if you take this information and then you kind of stretch it out, if you proportionately multiply it by things, it does not affect the R value. So multiplication does not affect correlation. In fact, you could even switch the X and the Y axis and the R value would not change. Here's why that is happening. Because this is the formula. You have this information for the x's and this information for the y's. So if you had done commutative property of multiplication and switched the order of these 2 parentheses sets, it wouldn't change the value of the R. Okay, so adding, subtracting, multiplying, and dividing do not affect the correlation coefficient. The only thing is if you multiply one of the variables by a negative, then it just ends up changing this to the negative version of the correlation, but the number itself, the strength, still stays the same. So that's easy to remember. Just no change, if anything, only from a positive to a negative. All right, so that is all of the lesson to learn for this assignment. Your homework is from page 24 to 29. Some of this is multiple choice. Some of this is work that you need to work through. Let's see here. I think I remember in the past students wondered what's the explanatory variable here. And we're going to attempt to have the fat in grams predict how many calories are in the food item. Okay, so go ahead and set that up that way. And then on this problem where we have this big paragraph here, just wanted to kind of let you know you got to search through here and find all your little sets of information so that you can then get the equation of the line. Okay, so there's your hint for that. And then here comes and starts the kind of the multiple choice. This one's a question about the correlation coefficient, what affects it. And here's a problem on reading the computer printout, just like we had learned on Friday. And then finally, we've got some multiple choice to finish this out. All right, so please use the rest of the class wisely to get as much of this done. What you do not finish is homework.